Hi, this is Alana Lynn doing the final physics lab. My project's objective was to predict the length of a year on several of the planets in our solar system. The results were close to the actual data given on the link from the WebDesign page. I used the data on that web page to construct a model of the solar system using Python. I chose to exclude Uranus, Neptune, and Pluto in the visual because a to-scale model made the model difficult to see. To further conserve screen space, I made the sun a point at the center of the screen that can't be seen. The code uses the average velocity of the planets and the gravitational force on the planets to calculate the instantaneous velocity and update position. I put the origin at the sun and let all the planets originate to the right of the sun so the velocity would all be in the positive y direction at the start of the model. These are the specific calculations for Earth in my Python model. Earth is a sphere with a radius to scale with the rest of the planets, but large enough to be seen with the size of the orbit. The mass and position are actual data from the web page. Inside the while loop, I calculate the gravitational force of the sun on the Earth, and then use that to update the velocity, and use the velocity to update the position. Then I use its original position and see when the new position is close enough to the original position to be counted as a full orbit. When that happens, it'll print out how many days the orbit was to the shell. These calculations were done for each planet. Then, a window pops up that shows the planets orbiting. Mercury and Venus are yellow, Earth is blue, Mars is red, Jupiter orange, and Saturn is also yellow. The shell prints multiple calculations for some of the planets because it prints any update that is within a certain range of the original position. I averaged those and calculated the period of revolution, a year on each planet, for each planet relevant to a known Earth year, 365.2 days. Most of the calculations were very close to the actual values, with the exceptions of Mercury and Jupiter. That discrepancy could be due to many possible sources of error, such as using the average velocity as the initial velocity. At the start point where the planets are in their orbits, their velocity would be above average. Since I used the average velocity, it makes sense that the years are longer because the planets are traveling slower than they actually would be at that point. Occasional gravitational pulls from other planets could also cause errors. I neglected these because compared to the force of the sun, these planets' forces are negligible, but in actuality, they would affect the period of revolution a little bit. That's it.